Today, we're going to learn to use textures in the Vertex shader. Let's go! For the last few weeks, we've been talking about Vertex shaders. Last week, we talked about performance optimization, and I showed you a few things that you can do to move math from the pixel shader to the Vertex shader to improve the performance of your shader. If you haven't seen that episode yet, it's a great one. I'll put a link down in the description. Today we're going to talk about using textures in the Vertex shader. There are a couple of tricks and gotchas that I want to make sure that everyone understands. So let's just jump right into Unity, and then we'll take a look at the same things in Unreal in a few minutes. Okay, so we're just going to start from scratch here, and I'm going to go ahead and bring up my Create Node menu, and we're going to add a texture sampler. We're going to use this Sample Texture 2D node, and this is what normally samples textures for us. So let's go ahead and pick a texture sample here, or texture here, and I'm just going to use this nice vase of flowers as an example. And so now that I've got my texture selected, I can just wire this directly into base color, and that's going to work just fine. You can see that now my texture is being sampled, and I can see the result here in my main preview. So this is the regular way of sampling a texture, and this is happening in the fragment stage or the pixel shader of my shader. But what if I want to do it in the Vertex stage? What if I want to sample my texture in the Vertex stage? Can I drag this over here and connect it into my Vertex stage? No. Shader Graph is not allowing me to connect this node to any of the input ports on the Vertex stage on these blocks in the master stack. And even if I have this custom Interpolator node here, if I select my Vertex stage, hit the space bar and pick custom Interpolator, so I'm creating my own input block in the Vertex stage, I still can't connect it there. Why is that? Why am I not able to connect my texture sampler here to the Vertex stage? Well, let me back up and explain what's going on here. One of the important tasks that a texture sampler does is to figure out what MIP level of the texture to sample. And I'll briefly explain what that is. So a texture in a real-time application is more than just a single image. The game engine actually stores a whole chain of images where each image is half of the resolution of the previous one. So you can see here I've got the MIP maps showing for my vase of flowers. This is the original resolution. Then I've got one that's half the resolution of that, one that's half the resolution of that, and so on, all the way down the chain. As the 3D model moves further away from the camera, or as the angle changes between the camera and the surface that the image is applied to, the graphics hardware figures out which of these images to show you. So instead of just sampling the single highest resolution image, that texture sampler node is actually telling the hardware, figure out which of these images I need to sample based on how far away or at the steepness of the angle of the image compared to the camera. So this process ensures that the image that you see, the texture that you're sampling, always looks nice without any shimmering or flickering. Because if there are more pixels in the texture than there are pixels on the screen, then every frame it has to decide which of those pixels to show you, and the result is going to be some shimmering or flickering, and that kind of sizzle is what we're trying to avoid, which is why we have this whole chain of MIP maps. So by default, the hardware is always trying to decide for every pixel that it's rendering, which MIP map should I be sampling from? You might be asking, well, how does the hardware do that? How does it figure out which of these MIP levels it wants to sample? Let's take a look at this little diagram here. So here is the pixel that's currently being rendered. And if I want to figure out which MIP level to sample, well, what the hardware does is it measures the distance between the UV coordinates in this pixel and the UV coordinates in the pixel just above it and the one just to the side of it. And by looking at the distance in UV space between the currently rendered pixel and its neighbors. The hardware is able to determine which MIP level to sample. So if this difference in UV space is large, it means we need to sample a smaller MIP level. But if the UV distance is small, it means we need to use a larger MIP level. So for every pixel that it's rendering, every time it's sampling this texture, it's doing this math and comparing the UV distance between the neighbors. So now I hear you saying, wait a second, in the Vertex shader, there aren't any neighboring pixels. Ah, nice work. You just figured out the problem. The texture sampler wants to figure out the correct MIP level by looking at the neighboring pixels, but there aren't any pixels in the Vertex shader. So we can't use the standard texture sampler in the Vertex shader. We need to do something different. So let's switch back to Unity here really quickly. And I'm going to select the Sample Texture 2D node. And we're going to open the Graph Inspector over here and take a look at the settings that this node has. You can see that there's this drop down here called MIP Sampling Mode. Now this sounds promising. By default, it's just set to standard MIP sampling mode, but if I drop this down, you can see that there are several other options here. I'm going to set it to LOD, or level of detail, and if I set this MIP sampling mode, now you can see there's this new input port here called LOD. And what this is going to allow me to do is, instead of me telling the graphics hardware with this sampling node, hey, figure out which MIP level I need to be sampling, it's just going to expose a port here, or a value, where I can tell it what MIP level mode I want to sample. So if I wanted to, I could create a whole network of nodes to do the math, to figure out, to develop my own technique for calculating the MIP level. But in my case, I'm just going to type in a value. So you can see if I type a value, a value of 0 means the highest MIP level. So 0 is going to be sampling this large version of the image. But if I type another value in here, say like 5, now you can see I'm getting a blurrier version of the image here in the preview. And that's because it's sampling a MIP level that's further down the chain. This is a much lower resolution version. So I'm just going to set this to 0 for now. But the takeaway here is that now that I have my sample texture node set to LOD for the MIP sampling mode, now I can grab this and I can connect it to the ports on the master stack for my Vertex shader. So now I've set it to Custom Interpolator, and I'm passing the color from my sampled texture into the input port here in my Vertex stage. But now I want to be able to see it in the fragment stage, or the pixel shader. So what I can do is open this up again and come under Custom Interpolator, pick the Custom Interpolator node, and you can see that now the results that I'm passing into my Custom Interpolator here are showing up in my preview here. So I can just directly connect this to my base color in my fragment stage, and boom. Now I'm sampling my texture in the Vertex stage and passing it into the Custom Interpolator here. Then I'm accessing that data in the pixel shader or fragment stage and passing it out to the base color in my pixel shader. Cool, that's fantastic. And we can see our results over here in the main preview. But taking a look at this, you might be asking, why is it so chunky and blurry looking? Like, this doesn't look like the vase of flowers at all. Well, understanding that kind of goes back to what we talked about last week. Our texture is only being sampled at each of the vertices in our mesh. And our mesh is made up of not a whole lot of vertices, actually. You can see the individual points here, and the pixels in between the vertices are just basically blending. So I have one vertex here, and to figure out the colors in between, there's some linear interpolation happening. And that is why this node here is called a custom interpolator, because the data that goes into my vertex stage here, between this and the fragment stage, it's getting linearly interpolated from one vertex to the next. So what do we learn from this? Well, and let me show you one other thing here. If I switch my main preview from using a sphere to using a cube, you can see that now I can't even see my image at all because I only have 4 vertices per side of this cube. And these vertices are actually in the corners of the UV space of the image. And so the sample that I'm getting here is just these little white boxes that are in the corner of my image. And so I'm not able to see my image at all. So there are a couple of takeaways to learn from this. Number one, when I sample an image in the Vertex shader, I want to be sure that I have enough vertices to cover or to be able to see the detail in my image. Because as we could see when we were sampling the cube, if there aren't enough vertices, I just won't see any of the texture detail at all. And then number two, and this is kind of similar to number one, we want to make sure that we're sampling a texture that has a fairly low amount of detail. Like if I were to switch this image over to something like a gradient, let me see if I have a gradient to select here. Yeah, so if I select this gradient here, now you can see that because there's a fairly low amount of detail in this texture, I get pretty good results. And I can get the same results if I connect to the vertex stage or the pixel stage. So this is what it looks like if I'm sampling the texture in the pixel stage or the fragment stage. And then if I switch it back, this is what it looks like if I connect it in the vertex stage. And so for this particular texture, I'm really not seeing that much of a difference. So this is a good candidate for doing it, the sample in the vertex stage. But I need to be careful when I'm doing these samples in the vertex stage that I'm not trying to sample a texture that has too much detail in it, because it just won't come through. Most meshes that are created for real-time applications have a relatively low vertex count. And so in general, the results that I'm going to get from sampling a texture in the vertex stage are going to be blurry like this. And then so I need to make sure that whatever texture I'm sampling, the detail in that texture matches the density of vertices that I have, so that detail can come through. Right now I'm using a texture here that's kind of like, it's a 512 image. And if I lower this so that I'm sampling lower MIP levels, what you're going to see here is that there's actually very little difference in the look of my image as I sample a lower and lower MIP level. And so the takeaway is that the detail that I have in this texture kind of goes beyond what I'm able to represent with the number of vertices that I have here in my preview sphere. All right, so we learned how to sample textures in the vertex stage, and we learned how to bring the results into the pixel stage to use in our shader. We learned about MIP sampling and calculating MIP levels. And we learned about being careful that the detail that we're sampling our vertex stage texture doesn't exceed the density of the vertices that we have available for displaying that information. All right, so a little bit later in the series, we're going to use this idea of sampling textures in the vertex stage for a couple of really interesting applications. But not today. We're going to end it here, and I'm going to switch over to Unreal and show you how to sample textures in the vertex stage there as well. All right, here we are in Unreal, and the first thing that I need to do is go ahead and add a texture sample node. So here's our texture sample, and we're going to go ahead and grab the same flower texture that we used in Unity. And by the way, there's nothing magic about this flower texture. A lot of times people ask me in the comments like, hey, where do I get that texture from? And you can use any texture for this, so don't worry about finding the exact vase of flowers that I'm using here. Okay, so I'm gonna take my texture sample and we're just gonna connect it directly to my base color. And now you can see that I've got my flowers displayed nicely here on my preview sphere. This is the standard way of doing texture samples where we just plug them directly into the pixel shader and we're doing our sample in the pixel shader and everything's great. But this video is about Vertex shaders, so how do we do a texture sample in the Vertex shader? Well, what we need to do is add a Vertex Interpolator node. And what this node does is anything that's plugged in here to the left side is going to be happening in the Vertex shader. So I'm just going to go ahead and take my texture sample and plug that into the VS input socket in my Vertex Interpolator. Now this magic node, what it does is anything that's happening over here is being done in the Vertex shader, and then it interpolates that across to the pixel shader so that the results that I get out over here, I get happening in the Vertex shader. So if I just plug this directly into my base color, now I'm sampling this in the Vertex shader, it's getting interpolated, and then I'm able to pull the results out of this right side here and plug it into whatever's happening in my pixel shader. And in this case, I'm just plugging it directly into my root node. And the results that we're getting are super chunky. Like if we switch back to doing this in the pixel shader, we've got tons of detail here, lots of really sharp detail. But if I'm doing it in the Vertex shader, wow, my results are super chunky. And the reason for that is because we're only sampling our texture once at every vertex. And this particular vertex right here is a really good example of that. So we're doing one sample here in this kind of light green, lime green area. And then the results are getting interpolated as a gradient from this pixel to each of the neighboring pixels. So you can see these little lines here going across. And that's because this Vertex Interpolator node basically says, okay, this is my sample, and then for every pixel in between, we're just going to compute the sample here and the sample there and make a gradient in between those two. That's what's happening in the hardware between the Vertex shader and the pixel shader. So a couple of things that we can learn from this, just to kind of drive my point home here, I'm going to switch to the cube as the preview for my shader here. And now you can't see any of the detail at all from my texture image. And why is that? Well, my cube only has 4 vertices per face. So I have a vertex here in the top left, in the lower left, in the top right, and the lower right. And we're sampling our texture in those 4 positions on the image. Top left, top right, lower right. And if we look closely at our texture here, those positions are just white. And so the result that we get here is just white. So the takeaway from this is we need to be careful when we're sampling textures in the Vertex shader that we have enough vertices to actually be able to see any of that detail at all. So I'll just switch back to my sphere preview image here. And now you can see that I have some detail. If I set this to wireframe, you can see that there are a lot of vertices here. And so I'm able to sample at each of those vertices and see the detail in my texture. But for my cube, if I switch to wireframe here, you can see there are no vertices at all except right on the corners. And so I'm not getting any of the visuals from my texture at all. So as I was saying, the takeaway is you need to make sure that the amount of detail in your texture that you're sampling in the Vertex shader matches the number of vertices that you have in your mesh. You know, meshes that are optimized for real-time applications are usually trying to be as low poly as possible. And so if you sample a very detailed texture, you're going to lose a lot of that detail unless you crank up the vertex count in your object, which is not really recommended. So you need to make sure that the amount of detail in your texture and the amount of detail in your mesh match. So it might be a good idea to just stick with simple gradients and that sort of thing in textures that you're sampling in the vertex shader, so that you're not overpowering the number of vertices here with the number of pixels that you have in your image. All right, in future videos, we're going to go over some really interesting techniques and ways that you can use texture samples in the vertex stage, but we're not going to do that today. We're going to come back to those in coming weeks. Next week, we're going to talk about vertex displacement, and I'm going to show you ways of moving vertices around and changing the shape of your object. Hope you come back next week for that, and in the meantime, have a great week, everybody.